Hello, everyone, and welcome to the Viking Code School Final Project Demos. My name is Eric Trotman, and I run the program over here. And what we are doing today is we have a team. We have three teams of students from our immersive program. They kicked off in October. They've been working for 16 weeks to pick up an insane amount of technologies, not including all the time they spent building up to the program and getting ready for it. And they've been putting in countless hours over the last, again, it's 16 weeks plus a lot. I've been through, what is it? What have you guys picked up? I mean, it's HTML, CSS, Sass, Bootstrap, basic Ruby object orientation, testing in Ruby, Sinatra, web scraping, APIs. Let's see, databases, SQL, working with Active Record, forms, authentication, authorization, security, testing on Rails, working with sending emails. What am I missing here? Task queues, JavaScript, jQuery, AngularJS, single-page apps, and a variety of technologies that I don't even know that are going to pop up in some of these projects that they've been doing over the last 2 weeks. Basically, the overall format of these projects is they've grouped up into teams and they've used an agile development workflow to over the last 2 weeks do 2 full sprints. And what that means is they came up with these ideas themselves. They created mock-ups, they pitched the ideas, they formed into teams, they put on their product manager hats and came up with user stories, converted those user stories into points values as an engineering team, built out an agile backlog, chopped it up into agile sprints, and then every day they've been having scrum meetings and code reviews, acting as real engineers on real engineering teams while they've gone through and produced these projects. So this is officially the end of Sprint 2. This is their official demos and presentations, and then we have 3 really great teams who are going to show you some pretty cool projects. So I won't steal the thunder by introducing the project specifically. I think what we can do is just kick off. In terms of the way the format's going to work, we will do generally it's broken up into 10 minutes to demo the product itself, and then 10 minutes to demo the underlying technical. That could be a little bit fluid, but after 20 minutes we'll break and have about 5 minutes of questions in between. And so if you want to ask questions, feel free to do so on the Q&A section of the GoToWebinar viewer. And otherwise, I think we're in good shape. We can kick off.
There it is. So we have created an application that we call the Reddit Visualizer. And it is a way to basically grab some big data from the Reddit API and organize it into some really cool representations for your viewing pleasure in the browser. So I'll just quickly introduce us all here. All the way on the left, or at least on my left, as far as I can see, we've got Anthony Fuentes, Catherine Kwok as well, operating the slideshow right now. Christian Carey, that's me. Felipe Suero, I can't see you, but I think you're here. And of course, John Popinuk, aka JP, the man himself. So, just going to give you all a little preview of how this is going to work. Basically, same kind of structure we've been seeing so far. JP is going to go through a demo of what it's like to actually use the Reddit Visualizer, show you all the different features, and let you know how it looks in action. And then at that point, you will probably have your mind blown a little bit. And so we're going to go into a technical overview just to explain the magic behind what you're going to see. And after that, we'll wrap up with a little bit of questions as per usual, in case you saw something that was confusing or just interesting that you want to know more about. So with that, JP, take it away.
Sure, yeah. So the actual project was built using a stack of Ruby on Rails, Angular, and D3. D3, for you who are uninitiated, is the library that we use to do all the graph rendering, all the visuals and stuff like that. For our workflow process, we used an agile workflow. We started off by creating user stories for the application that we were building. We broke them up into sprints, and every single morning we would have a scrum. We would talk about what we were doing the previous day, what we were planning on working on, and what blocks we were hitting. We'd meet in the afternoons and at the end of the day to discuss our progress, any problems we had. We kept in touch throughout. And yeah, over to Felipe.
So, a quick overview of what Reddit is for those of you who don't go on the internet, apparently. Reddit is a social news site where you can post, read, comment, and rate comments submitted by users. You can sort of think of it as a link aggregator where links are rated by popularity. Reddit is made out of a lot of smaller communities focused on particular topics. You have, for example, Our Politics, a subreddit focused on politics. You can think of these as like forums of their own or anything like that. These all get aggregated into one main page in the live feed, but that's not super relevant to us right now. The Reddit visualizer has an objective of letting us explore the connections between these subreddits by checking users that have posted on particular subreddits and see what subreddits they've commented on. The data gathering we have right now is a sort of shallow data gathering with the intention of deepening later, but we'll get into that after the demo. So yeah, back to JP, I think.
Sure, yeah. Cat, okay, there, I got it. Nope. All right, can everyone see my screen? Yep. Cool. Everyone hear me? Cool. So this is the site, Reddit Visualizer. When you first visit the site as a new user, you will get a little help pop-up. It's a modal. It's cookie-based, so if you revisit the site, it will not show it to you again. You have me guiding you through it, so you don't need to read it. But if you do want to revisit it, you can always click on the Help tab down here, or the Help link, and it will bring it back up. You can review it. Gives a little brief overview of what everything means on the page and some of the actions you can take. So yeah, let's get into it. All right. So this is the main one. This is the main page. This is the graph right here. When you first load it, it will default to Ask Reddit. This is the subreddit that you are viewing connections based off of. So all of these nodes right here represent other subreddits that you can visit, and they are connected to Ask Reddit by an algorithm that determines how connected they are. The width of each of these links represents just how connected it is. So you can see that Croatia is relatively less connected to Ask Reddit than something like Overwatch is, which has a thicker line. The node size itself represents how many subscribers there are to that given subreddit. So if you want to, explore this one of its connections, connected subreddits, you can click on the node. Right. A little explosive sometimes. So the purple color represents the node that you are currently viewing. So that means that Explain Like I'm 5 is the active subreddit that we're viewing. Again, you can see all of its connected subreddits, and you can continue to click on other subreddits. If you don't feel like clicking on all, oh, and sorry, I forgot to mention, the green node means that it has connected subreddits. So at a certain point, or it's expandable. So at a certain point, you'll run into subreddits that don't have connections based on the data that we've already gathered. If you don't feel like clicking on all these nodes individually, there's always the Expand Subreddits button, which will expand the visible subreddits. So you can see here, there's some bluish gray colored subreddits. That means that they are a repeat. So NFL already exists on the screen somewhere else. I'm not sure where it is. Not too important. You can trust me. So yeah, you can expand again, zoom out a little bit. Yeah. So if you're interested in finding a different subreddit, you can always type it in up here. So let's go to something like Data is Beautiful. We have type ahead, and it will load that subreddit for you. If you want to find a path between subreddits, instead of having to search for it yourself, we can do something like the Silk Road, and we can look for a connection to news. So that will return the path for you, and it will expand them for you. So the Silk Road connects to Ask Reddit, Explain Like I'm 5, and then to news. If you want to visit the subreddit, you can always click on this link. There's a little bit of data over here about the subreddit, subscriber count, a brief description. It's the one that they provide on the subreddit itself, and you can click on any of its children. So the current node is the Sylph Road, and these are its connected subreddits. So you can also click to collapse a node as well. Its little subreddit icon up here if it has one available. And you can also, if you're curious about how two subreddits are connected, maybe a current event, something like that caused the Sylph Road to be connected to Pokemon trades. You have no idea what that means. You can click on the Sylph Road. You can click on Pokemon Go over here. This little Google icon means that it will Google the connection for you and show you in what way they are properly related. It's hit or miss sometimes, but yeah. You can see here the Sylph Road. It is, I don't know, it's part of the Pokemon game, the Pokemon universe, so that is how they are connected to one another. Yeah, I think there were no not safe for work subreddits that showed up on the graph as we have it right now, but if they had, they would be this bright pink color to let you know danger, or however you want to take it. Yeah, so that is a brief overview of the app. I'll pass it back over to Catherine. Bear with me.
I don't know where Catherine is. Is she still here?
Yes, I'm here. My camera seems to be cutting in and out, so it's disabled. I'm not sure what's going on. But I am sharing. You should be able to see the demo screen. So that was the demo, and I think Anthony will go over data collection and our gem.
Sure. So one of the main components of our app is collecting data so that we can visually render it for our users to explore. And the way we do that is by communicating with the Reddit API. And we thought it might be cool to make the methods and the logic that we have for communicating with the API public and available to other developers. So we actually made a gem. And there on our presentation slide, you can sort of see the main classes in our gem. The most interesting ones are the query object, the client object, and then there's some sub-APIs. So the query sort of contains things like the records that have been captured for a given search, the number of records captured, as well as the offset. When you communicate with the Reddit API, we were collecting lots and lots of data, and there's a single API request limit of 100 records. But the gem can actually handle sending multiple requests to collect more than 100 without requiring any sort of special input from the user, which was really helpful for us when we were collecting large amounts of data. And so once we use the gem to collect data from the Reddit API, we're persisting it to our app, or persisting into our database, which was fairly straightforward, thankfully. So each of our sort of sub-APIs return a subreddit or a comment or a post object, which you can call toHash on, which is one of its methods that maps that directly to an input that can be passed to an active record class to persist it to the database.
I've been muted. I'm sorry about that. So once we have the data from the back end that we want in the format that is going to be visualized for the front end, we send it over to data-driven documents, or D3, which is a JavaScript library that manipulates our web page and allows us to bind data to visual elements like SVG, HTML, and CSS. So the way it works is quite similar to jQuery in terms of you're able to select elements based on the type of element they are, or add attributes and styles to them. And D3 specifically also allows you to send in the specific data that comes from your object on the back end and tie it to every element that exists on that page. So we have this list of all these objects, and we enter them into our document and attach each node as they appear to the data that we receive from our backend. And the way that a lot of these nodes work is with force layouts. Pretty much the main function, the main part of D3 that we used is called force layouts, which allows us to set the physics for all of the interactions for everything on the graph. So you can see on that GIF on the right, this is one of our failed attempts where we were trying to get the physics to work with all the nodes and make sure that they weren't overlapping with each other, they were spreading out properly, and when you click on them, they would expand and everything would be visible and spread out. And so, without going too much into detail, the main things here were the charge and the gravity. Charge is the repulsion of nodes from one another, and gravity would be the attraction of every element to the center of our canvas. So depending on what numbers you put into these functions on the force layout, different things will happen with the interaction, with the graph interaction. I think that brings us to the end, actually. So that brings us to the next part of D3, which I think Christian will take over.
Sure thing. So we had every node have that static charge, as Catherine mentioned, to sort of push all other adjacent nodes away. However, when you get to having a certain amount of nodes, the charge is actually not enough just because there's not enough room, and they'll begin to flatten out and overlap with each other. So what we had to do is implement some collision detection. And the other part of, or the new problem that introduces is it can just be computationally pretty intense to essentially look at every single node in the tree and then look at every other node and check if they are touching. So the solution to that new problem was to use something called a quadtree. And a quadtree is a data structure that D3 can kind of provide the bare bones implementation of sort of constructing a quadtree, and then lets you interact with it however you like. And what a quadtree actually is of course a tree-like structure with made up of nodes that have children, which are other nodes. But in a quadtree, every node will have exactly 4 children. And so you can see that little image over there is sort of the data representation of it. But in practical usage, a quadtree is generally representing a 2-dimensional space. So in our case, a quadtree is representing our entire SVG canvas. And you can imagine that traversing the quadtree is sort of like zooming in on the canvas. So the root node of the quadtree encompasses the entire canvas. That root node has 4 children, each of which is 1 quadrant of the entire canvas. And then those nodes have 4 children, each of which is a quadrant of themselves, and so on. And what's nice is that as soon as one quadrant that you're in contains one and only one data point, which in our case are the little bubbles that make up a subreddit, it doesn't have to have any children anymore, because at that point, you're just looking at the data point contained within that quadrant. So with this example, the forest part of that quadtree, or of that quadrant, that square, that quadrant only contains the forest and nothing else. So on the diagram on the right, the forest node, which is that green node, has no children because there's no more data to be found. So the way that this lines up with our application and the way that this helps with collision is that we've organized all of our nodes into this quadtree. So when we look at a single node to check if any other nodes are colliding with it, we start comparing it to the nodes in our quad tree. And as soon as we hit a quadrant that must be out of bounds of the node we're looking at based on its size. For example, if we're looking at a node in the bottom left corner of our screen, we can ignore the top left, top right, and bottom right quadrants of the canvas, and so on. And so basically, we're only checking for collisions with other nodes that are inside of the same small section of the graph. And so as you kind of zoom in on the quad tree, you're just eliminating large chunks of the canvas, so you're not checking nodes that just could not be colliding with the node that you're currently looking at. And so to put that into concrete terms, basically what that does is it will take the speed of our collision detection to n squared, where n is the number of nodes, to n log n, where n is the number of nodes. Which when we have over several hundred nodes in the canvas is pretty crucial. So that was kind of a cool algorithm that we had to implement, and I think we have another algorithm to talk about, which is our pathfinding, and that's going to be done by Felipe.
So pathfinding was an interesting challenge because the way the data is represented in our database, I don't know if we covered this necessarily, we have two tables, a subreddit table and a connection table, and that's it. And the connection table is a join table that joins two subreddits with a particular weight. And ideally, right, we want to do a breadth first search in order to find which subreddits are most closely linked to each other. And that's not terribly difficult to implement. You build a queue, you start putting stuff in the queue, you pop them out until you find what you need. But returning a path is a little bit more complicated because the way the queue is built, you can't really keep track of what level you're at. So what we did was essentially generate a tree with the first node as the root node. Every subsequent node gets put into a container object that has a parent pointing at its parent node and its ID, so we know what subreddit it is. And this sort of structure forms a giant tree until you find your destination, and then we can just climb back up the tree and return what we're finding. This is like 50 lines of code, and it works for what it does. We had some issues when we hit really high numbers due to the fact that the original data structure we're using was a hash as opposed to a struct. And in memory terms, that meant that we were building this gigantic object in memory, and we were causing Rails to crash when we were doing particularly deep searches. So what wound up happening is we modified it so that it would use structs instead. And there was one particularly interesting bug where structs don't work like hashes. You can't key into them. They're location-based, at least when you're creating them the first time. And that caused us all kinds of headaches. But the general actual algorithmic idea is very, very simple, and it works really well. Time is O of n just because you need to check every node regardless. We have a few error handling cases where we make sure, if a child node is the parent node, we ignore it. Right, so if you see Ask Reddit down the line while you're going from Ask Reddit to point B, you don't really want to go there. That'll cause you a permanent loop. And we keep track of nodes visited to avoid any cycles within the graph. And yeah, I think that's it for that algorithm.
Great. If I'm not mistaken, that wraps up the high-level overview on the technical side. So we just would like to know if anyone has any burning questions.
Just a reminder, if you're here, you can ask questions out loud. If you're in the app, feel free to drop the questions in the app, and we'll be able to see them pop up. So fire when ready.
What attracted you guys to force layouts for your visualization?
I can take that one. So what's really cool about the force layout is that you don't have to specifically say where you want all of your nodes to be. You never have to supply, for example, a hard-coded X and Y value for the nodes. And since we are dealing with dynamic data, we don't know what data is going to be on the screen because it's always based on user interaction. What the force layout allows you to do is essentially have a formula or an algorithm to say, I always want the graph to look this way, and behave according to these rules. And as long as you tweak those rules correctly, then you'll always end up with a graph like this where everything is fanning out in a reasonable, somewhat predictable structure.
So we have a question via the app from Alexa, which is, I think, basically, out of all of the subreddits out there, how deep were you able to map in your app?
At the time of right now, we have 4,400 some subreddits stored with over 30,000 connections. The task to gather those will continue going indefinitely, basically. So at some point, we will have mapped out every subreddit.
I checked right before the presentation. We're at 7,174 subreddits and 43,110 unique connections.
Okay, more than I thought.
Wow, are you guys gonna fill up your database at any point? I know that Heroku has a limit on how many rows they'll let you have, because I ran into that on a previous project.
We did. We actually had to
may
upgrade
have.
10 million one.
Yeah, we've upgraded.
Nice.
What queue are you using to manage your background tasks?
Heroku has a thing called Task Scheduler, because we want to sort of reset where we start the date every time. It's just running every hour on the hour with a rake task that has a predefined amount of subreddits to scan for.
What sort of questions did you build this visualizer with in mind? Sorry, that's not a very good way of phrasing that. What sort of problems do you envision solving with this?
Well, if no one else wants to take it, I'll take it. I just feel like I'm hogging all the questions. You can really think of it more of as a high-level proof of concept. One of my big things right now is that people really underestimate how much publicly available, gatherable, and usable data there is. I think this is a pretty strong demonstration of the fact that, there are these trends that we can gather without much difficulty. Someone with more resources, more time, and more dedication could gather even more. At a lower level, it answers the question of, okay, I like this subreddit. What other subreddits would I like? And you can go click on a node and see, oh, I really like Ask Reddit. Here's where people in Ask Reddit are posting.
Yeah,
Good
it's
answer, thank you.
definitely more of an exploration of sort of how this data looks. Yeah, we're all Redditors, so we were pretty interested in what this graph would look like and how we could interact with it.
This isn't a question, but I really like just clicking the expand subreddits button a lot of times. At first, I was playing around with this and going, okay, that's kind of interesting. But you get a really big graph, you click the expand subreddits button, and this explosion of data. It's really fun. I like this.
Well, if there are no more serious questions, we have one from the app which says, are there any particularly interesting or entertaining links that you found while spending far too much time on Reddit?
I actually wrote a blog post that has a few of those, and I'll link it in Slack, I guess. I don't know where I could link it, but the answer is yes. There's a lot of kind of neat, different types of links you can find. For example, we found one that was, all the Blizzard communities are tightly linked together. If you explore the gaming communities, there's a lot of them that get tied together. There's something called Not Safe for Work Reddit clustering where you don't find any Not Safe for Work subreddits, and then all of a sudden you find all the Not Safe for Work subreddits because they're all tied together. So, yeah, there's a lot of fun stuff to poke at, and it's definitely interesting to go through and be like, wait a second, Croatia, how did that get there? And then finding that it's connected to Europe, and oh, look, I wound up at soccer again.
I think there was actually another point when we first started collecting data. It was on Valentine's Day, and we actually found that there was a lot more connections between general subreddits and not safe for work subreddits, and that seemed kind of fitting for Valentine's Day. Ask Reddit had a lot of not safe for work connections, whereas later, after more data had been collected, they're very rarely seen.
With your pathfinding algorithm, Are there any optimizations implemented similar to like the A-star algorithm or Dijkstra's algorithm, where it tries to find the shortest path relative to a straight line to your endpoint? Are there any implementations that with this pathfinding similar to that, like to find a certain subreddit?
Not really. I actually just considered the A-star implementation. I just wasn't 100% sure I could get it working with the data set we had and how it was structured. But the bottom line is no, it's a very simple methodology. The majority of the sanity checks in it are like, does this subreddit exist? If it doesn't, well, then don't even bother searching anymore.
And I'll add on to that. Part of that too is that our weights of our connections don't necessarily relate to a quicker connection or anything like that. So we were sort of reduced to doing a more general implementation of the pathfinding.
All right, so let's do one more question here, and then we should probably wrap up. Another question from Alexa in the queue. It's why use a SQL database as opposed to a NoSQL database for what seems like a big data problem?
I can take that, although, hold on. Sorry, there was a garage motor going on. So we had kind of talked about doing a NoSQL database and using Mongoid to host our data, and in the end we decided the trade-off for using a MongoDB database or a NoSQL database was going to be just so we could have our data in the proper format that we wanted for displaying everything. But our data is fairly straightforward. And so it was sort of trivial to model the data in the way that we wanted. And it was more of a, we're familiar with Postgres, and we felt that the trade-off wasn't that big of a, I guess, reason to go to NoSQL. And the other part of that is NoSQL would have been a bit larger, and Heroku has constraints on database size limits, so we did have to upgrade eventually, even with Postgres, and I imagine we would have had to upgrade a bit sooner if we had used NoSQL.
Excellent. Well, thanks a lot, you guys. Thank you, everyone. This actually wraps up all of our presentations. So everyone who's in the cohort, thank you guys for presenting. Thank you for putting the projects together. For everyone who's watching this from outside, I appreciate you guys checking out what we're doing over here. If you have any questions, feel free to reach out. You can do that via email or on Slack if you're on Slack. And otherwise, just want to say thanks a lot, and I hope you guys have a great afternoon, evening, noon, or night, wherever you are. Cheers.